Hi, my name is Affyan, and in this video I will show how to solve an initial value problem using Euler's method. I'll explain how the method works with a diagram, then demonstrate the solution using Excel, and finally compare it with the exact answer. Euler's method helps approximate solutions to differential equations. It uses a series of tangent line approximations, as you can see here, to follow the curve of the solution. The formula is yn equals yn minus 1 plus h times f of xn minus 1 yn minus 1, where h is the step size and f of xy is the right hand side of the differential equation. As shown in my diagram, we begin at the initial point of x0 and y0 and move forward using the slope at the point to estimate the next value. This process continues step by step, producing a sequence of approximation for the solution curve. The smaller the step size h, the closer the approximation is to the true curve. Here, I've used the Excel to compute Euler's method with the step sizes of 0.05, 0.2, and 0.1, each with three important columns, x, y, and f of xy. X to show each increment of step size h, y to show the approximated y values, and f of xy based on the differential equation of x squared plus 1 over y. I use the Excel formula for the first row of f of xy, which is the first row of x, c19, to the power of 2 plus 1 over the first row of y, which is d19. In each row of x after the first, I use the first cell in the list, which is c19, plus the absolute cell of e15, which is the step size. For each row of y after the first, I use the first cell in the list, which is d19, plus the absolute cell of e15 times f of xy. I did the same for the other two examples. As we scroll down, you can see that when x equals 1, the approximate value of y when x is 1 using the Euler's method is 1.91293, 1.90948, and 1.91138. This shows how Euler's method progresses with each step from the initial value. Starting from the equation dy dx equals to x squared plus 1 over y, we will multiply both sides by y, which gives you y dy dx equals x squared plus 1. We will now move dx to the other side, which will give you y dy equals x squared plus 1 dx. Now we will integrate both sides. So integrate y dy equals to y squared over 2, and integrate x squared plus 1 dx equals to x cubed over 3 plus x plus c. To get rid of y squared half, we will multiply both sides by 2. This will give you y squared equals 2x cubed over 3 plus 2x plus 2c. Since 2c is still a constant, we will rewrite it as c. With the general solution we have gotten, we sub in the initial condition, which is when x equals 0, y equals 1, which I have done so here. So with this, to get rid of the square root, we square both sides, which equals to c equals to 1. Now that we have the particular solution, we can find the exact value at x when it equals to 1 by subbing in 1 into the equation, which leaves us with 1.91485. Now we compare the exact value to our Euler estimate of 1.91293, 1.90948, and 1.91138 respectively, and get the approximation error of 0.0191568, 0.005370922, and 0.003474941 respectively. This shows how Euler's method gives a close approximation. Thank you.